Greetings, scholars. Let's do part 15. This is about momentum, and we're going to roll in kinetic energy as well. What is momentum? I'm going to let you choose from a few different equations. Okay, so answer the questions now. Yay, I'm hoping that you remember that momentum is a little p. It's what? mv, mass times velocity. Momentum is always conserved. So now let's talk about this. What if I have a collision? Remember we talked about the conservation of sorry, I cut myself off. We have the conservation of momentum. What that means is that your initial momentum equals your final momentum. I can put a little f down here. What about if you have a collision? So in other words, I've got two objects that are going to smash into each other. Sometimes they're going to bounce off, and sometimes they're going to squash together and continue on. So in general, I can always say that my M1 V initial, okay, plus, I'll use a slightly different color, my M2 V, I'll say V2 initial, I should say 1, right, is going to equal my M1 V1 final plus my M2 V2 final. That's always true. So now how can we apply this to the different types of collisions that we have? Let's talk about this. The first thing that I want you to do is tell me what types of collisions do we know. There's two types of collisions. This is a free response question. Please answer correctly. I'm counting on you. Go ahead and do that now. Hey, I'm hoping you wrote elastic and inelastic. One of them is bouncing, one of them is not. What do you think? Well, I think of elastic as bouncy, so these are where they bounce off. Okay, and the inelastic are where they stick. Let's see how we can apply this equation to both situations. You just do. You apply it. It works every time. If I've got M1 V1 naught, okay, and I've got M2 V2 naught, let's say this one is still, so it's not even moving, but M1 V1 is moving. Let's say that it hits M2 V2, and now let's say that M1 V1 stops, and M2 V2 moves. Great. I mean, that's a situation. If it's that convenient, actually what ends up happening is that those two terms will cancel because they're zero. They're you don't even need those terms. One situation where it could be iffy, all right, is where you have this situation or this two cars and they're going to collide and bounce if they're moving opposite directions. So if you had something moving with a positive velocity and you want to call that to the right, if this object was moving to the left, you would need to make sure that you made that a negative velocity. And let's say that they bounce off each other and go back in the opposite directions. Guess what? If they go like this, now this first one is going back. And it's going to have a negative velocity. And in that case, this one has a positive velocity. So you have to be careful about the direction of your velocity. Okay, so I'm going to have you answer a question now. What do you need to be careful about? You need to be careful about your direction. And that is simply because if it's in the opposite direction, you'll have to use a negative velocity. How about another situation? What if you have two objects that collide and then they stick together and continue on as one object? So in that case, you would have something that is inelastic. Okay, so I've got my M1 V1 initial plus my M2 V2 initial. If these two objects stick together, okay, so here's a car, okay, and you know, technically this could be moving this way as well, like maybe it's moving slower, or it could be moving toward it. It doesn't matter. Regardless, it's going to be a collision of some sort, whether it's a head-on collision on the highway or unless it's a rear-end collision on the highway. These two objects are going to squash together and then continue on as one object. Here is the key to solving this. What do you know about the final velocities here, V1F and V2F? I'm going to have you answer the multiple choice question now. Why is that? Why do those two equal each other? I'm going to have you answer that question now. Look, if these two guys are connected, they have to. They're squashed together as one thing now. You can't have one move faster and then one move slower. I mean, they're moving as one object. So they have to have the same final velocity. So what if I rewrite all of this like this? Now I'm going to say I have my M1 V1 initial plus my M2 V2 initial equals my M1 plus my M2 times, I'm just going to call it VF because it is the same for both. Since it is the same for both, I can actually just factor it out. I'm factoring out the like term. Okay, so this is equal to this. I pull it out, and I just have VF times M1 plus M2. Boom. I think you can solve that. I think you guys are advanced in math enough to figure out how to solve for any of those terms. And so, there we go for the momentum portion. The next thing that I want to talk to you about is kinetic energy. Baby stuff, right? Kinetic energy is 1/2 mv squared. Okay, boom. Baby stuff. What if I tell you that I have an object that is moving at a specific velocity and has a specific kinetic energy? Let me give you a quantitative value of what I mean.